Good afternoon, Mr. Mutuya.
Now we are going to start from where we stopped, but let me assign, first of all, the place on the blackboard. After here.
Yeah, teacher, near recording on our day.
And you see the bottom line? Can you see the bottom line? This is the space we are going to use right now. Remember the other time we are dealing with oxidation of alkenes, and we are trying to identify the position of the double bond and then the structure of the alkene. Okay? If just give a review. If we could just look at what we looked at, we said that if you have got an alkene of the structure CH3, CH, double bond, CH, and then CH3. And then you're oxidizing that one. Remember we say that there is this carbon of the double bond, and then there is hydrogen of the double bond. If you can remember, you see that this bond is not broken down completely, and then the carbon is going to give us what? CO, okay? And then the hydrogen gives us what? OH. Not so. The hydrogen gives us what? OH. So in this case here, if you have this carbon here, it's going to give us C double bond O. Then this hydrogen is going to give us OH. Okay? Then we have our CH3. And then the same applies this one here. This one also gives us the carbon of the double bond gives us CO. The hydrogen is going to give us OH. And then we have CH3. So this one we say that is ethanoic what? Acid, which is CH3 COOH. So since there are two molecules, this one plus this one. So oxidation of this one here gives us, using potassium permanganate, acidified potassium permanganate, H plus, it gives us two molecules of ethanoic acid. Okay? That was one. Then we looked at the terminal carbon. If we have got the double bond placed on carbon number 1, for example, that one, CH2. This one, the double bond is placed on position number 1. Okay? We see that in this case here, this carbon here, if it is a terminal carbon, the carbon here gives us carbon dioxide. Then these two hydrogens here are going to give us what? Plus H2O. Then this one here will break just like this one here. So this one is going to give us CH plus CH3 COOH. That was our discussion the other time. Okay. Okay. We looked at this one here. That was our product. So the carbon dioxide comes from a terminal carbon. And then this one here, the water comes from what? The terminal hydrogens of the double bond. Now we are trying to look at identifying the position, the structure of the alkene. So this one we have already. I was just trying to give a review of what we discussed. Now, We can now ask a question. We can now ask a question. NB now. NB. Oxidation. Oxidation with acidified potassium permanganate identifies the position of the double bond, and hence the structure of the alkene. E.g., if on oxidation, we can now ask the question, e.g., if upon oxidation of an alkene with the molecular formula C4H8, if upon oxidation of an alkene with the molecular formula C4H8, carbon dioxide is produced. Carbon dioxide is produced. And the other products react with Brady's reagent to give a characteristic yellow PPT. They say identify the structure. Identify the structure of the alkene. Identify the structure.
Teacher, wait.
Oh. And hence the structure of the alkene. Identify the structure of the alkene. If upon oxidation of an alkene with the molecular formula C4H8, carbon dioxide is produced, and the other product react with Brady's reagent to give a characteristic yellow PPT. Identify the structure of the alkene. From what I've been discussing, carbon dioxide comes from where? What type of carbon dioxide comes from the terminal double bond also? So we are going to say that carbon dioxide comes or is obtained, carbon dioxide is obtained from a terminal double bond. That means that if you are getting carbon dioxide, then the structure, the alkene must have a CH2, or it can have a CH2 double bond. It can have H2C double bond. Either way. Then yellow PPT leads to what? A carbonyl compound with Bradley's reagent. So next is yellow PPT with Bradley's reagent. Yellow PPT with Bradley's reagent leads to a ketone. So we can have, for example, we can have CH3C or CH3. You can have CH3C double bond or CH3. Now, if we combine this one here and then that one, we can combine this one and then this one here. We can be able to get what? The structure of the alkene. So, therefore, structure of alkene is the structure of alkene we have this one here. We are combining this one here. The compound has got 4 carbon atoms and then 8 hydrogen molecules. So we combine this one. We can see that these are 1, 2, 3, 4 carbons. And then we have got how many hydrogens? This is 3, this is 3. Okay? 3 plus 3 plus 2 is going to have to give us 8. So the structure of alkene is going to have CH3, C double bond, CH2, and then CH3. So that one's going to be the structure of the alkene. That means that when you oxidize this one here, as we are discussing before, when you oxidize this one here, this one gives us what? CO. There was no hydrogen. This one's going to give us carbon dioxide plus water. Okay? So in that case, when we are discussing here time, we have now come up with the structure of the alkene. You remember, we said that when you have CH3, CH3 double bond, CH2. You oxide this one here. This one gives us what? CH3, C double bond, or CH3. Then this one gives us carbon dioxide plus water. So even if they don't give us water, we can come up with that. The moment you get carbon dioxide, then you must know that the other product must be water. Okay? So that's how you come up with the structure of the alkene. So this one is giving us CO. There is no hydrogen here, so they don't give us the OH. And now, when you get CO, 1, 2, 3, 4. That means that carbon has got 4 bonds. Therefore, the compound is what? Is obtained, which is what? The ketone. So that's becoming the structure of the alkene. Now we are going to start on reaction number 6. Reaction number 6, that is reaction of alkenes, reaction of alkenes with ozone. Reaction of alkenes with ozone. That is our next what? Reaction. Reaction of alkenes with ozone. Even ozone is also an oxidizing agent. But only that here, the product is going to be different. It's a mild oxidizing agent. So we first react ozone with a polarizing agent, which is what? Carbon tetrachloride, to give us the ozonide. But the ozonide is not stable. Then we can hydrolyze the ozonide in place of zinc and then ethanoic acid to give us the final product of the reaction. So the reaction is referred to as ozonolysis. Reaction is referred to as ozonolysis, the actual reaction. Are we through here? Are we through?
Yes, teacher.
Yes, teacher.
Now, if I give you some product, can you come out with the structure of the alkene now? If I say maybe carbon dioxide, carboxylic acid, you should be able to write what? The structure of the alkene with potassium permanganate. Now we look at what? Ozone. I'm trying to give these expressions because in the previous paper, they just give what? Complete the following, give what? Complete the following. They just wanted what? The students to explain the reactions. So you must be able to explain these what? Reactions. So when heated with alkenes, ozone is going to give us the ozonide, which ozonide undergoes hydrolysis to give us the final products. So you can say when heated with alkenes, in the presence of a polar solvent like chloroform or carbon tetrachloride, and then hydrolyze with water. When you talk of hydrolysis, means what? We are adding water, excess water. with water in the presence of zinc and ethanoic acid oxidation products are obtained. Oxidation products are obtained. Obtained. Oxidation products are obtained. But we say that ozone is a less mild oxidizing agent. So, but ozone, which is O3, ozone is a less mild oxidizing agent than potassium permanganate. Hence, products are not similar. Hence, products are not similar. Hence, products are not similar. IA. IA. Alkenes dissolved in carbon tetrachloride. Alkenes dissolved in carbon tetrachloride. React with ozone at a temperature less than 20 degrees Celsius to form ozonides. So if we have the alkene, we have ara CH double bond CH ara right plus ozone in the presence of carbon tetrachloride, temperature less than 20 degrees centigrade, you end up getting ara CH or CH ara, right? Then we have O. So that is the ozonide. This is our ozonide. That is our ozonide. Remember, we said that the ozonide is very unstable. The ozonide obtained is very unstable. So after forming this ozonide, this is now going to undergo hydrolysis with water in the presence of a carboxylic acid, for example, ethanoic acid, and then in the presence of zinc to give us the final product. We use zinc and then ethanoic acid so that the other products cannot undergo further oxidation. So we see that this process is referred to as ozonolysis. So the ozonide formed is unstable. And can readily be hydrolyzed with water. In the presence of zinc, and ethanoic acid. To form carbonate compounds. The carbonyl compounds here obtained are mainly i.e. aldehydes and ketones. Now we have our product, the ozonide, which is this one here. This ozonide now, which is this one, we are going to say R. We have our ozonide R CH or CH R prime. We have O, and then that is the ozonide which is formed in the presence of water. We are adding water. In the presence of zinc and ethanoic acid. Maybe I can write up. Are we through with this one? And I write up here.
Yes, teacher.
Yes,
Then.
teacher.
Huh? Only one line? Okay. I want to try this one here properly up so that it can be.
You're on mute.
So I.e. we can have R CH or CH R prime. We have O, that one. we are adding excess water in the presence of zinc and then ethanoic acid. We are going to end up getting, this one is going to give us what? 2 aldehydes. So we're going to have R, C, double bond, O, then H plus R prime H and then plus hydrogen peroxide. So in this case, both of these ones are aldehydes. Both of those are aldehydes. But one of the products also hydrogen peroxide. Now, if we are getting aldehydes, these ones are aldehydes. Since hydrogen peroxide is one of the byproducts, if you don't add their zinc and then ethanoic acid, these ones will undergo further oxidation to give us the carboxylic what? Acids. That's why we carry out hydrolysis in the presence of ethanoic acid and zinc. The zinc and then ethanoic acid stops further oxidation of these ones, give us the carboxylic acids. Now supposing we have this one here now. Two. If I have R, CH, double bond, C, R prime, then I have R, 2 prime. We are adding ozone, presence of carbon tetrachloride less than 20 degrees centigrade. We are going to end up having R, CH, O, C, R prime, R that, and then we have O, that way. So we have obtained the ozonide. We have got the ozonide. Then next we add water in the presence of zinc and then ethanoic acid. We get the final product. We get a final product, which is going to be, for example, now the ozonide, which is going to be R, CH, O, C, R prime, we have R prime, we have O.
Teacher.
Yes?
Teacher,
Yes, please.
on the first example up, on the R prime aldehyde, isn't there supposed to be on the products, the first example up?
This one,
The products,
the product.
on the R prime aldehyde, isn't there supposed to be a carbon?
There's supposed to be a carbon here. It's supposed to be, thank you, R, right? Then you have what? C. C. There's a carbon there. Thank you. So that's the first example. But we are saying that if you don't remove what? If you don't put zinc and then ethanoic acid, this one will further undergo oxidation to give up RCOOH. R prime COOH, RCOOH. We shall explain that one later. Now, we have this one here now. They're saying that now R CH or C R prime. We have R. We have O. That one. We are now what? Hydrolyzing. We are adding water in the presence of zinc and then ethanoic acid. This one is going to give us what? An aldehyde. Okay? Because there is what? Hydrogen. Here there is no hydrogen on this carbon. Therefore, this one is going to give us what? A ketone. So the product which you are going to get in this case here is going to be we are going to get RCH ROH plus you're going to get R prime C double bond O R plus hydrogen peroxide plus hydrogen peroxide. So you're getting a mixture. We have got an aldehyde, we have got a ketone, and then hydrogen peroxide as the product. Then the other example can you give, if there is no hydrogen between, then we are going to get what? Ketones instead. For example, example 3 is that if you have got R, C, double bond, C, R prime, then we have R, then we have R, 3, plus ozone. Plus ozone in the presence of carbon tetrachloride less than 20 degrees centigrade, we get ozonide. Which is ozonide is going to be, we can have what? R, C,
Excuse me, teacher.
Yes?
Excuse me.
Yes,
So
please.
for the second equation, R
The second
prime,
one.
R prime.
This one.
Yes, for the product.
The product.
Is it prime, R prime?
RC, O,
Here.
H. Then this one is going to be
The second.
this one here.
The second. No, that's the third. I thought that's this,
Which one?
the one where we found the ozonide.
This one.
Yes, that one. There are
Mhm.
products here at the end.
Here.
The C.
This
Yes,
C.
is it R prime or?
This is R prime 2. This is R prime.
Okay.
Yeah.
Thank you.
Okay. This R here. No, sir. This one has come here. This is R. Maybe I can just use an example. Let me just use here an example. Hope you have it copied here. If, for example, I have what? If, for example, I have 3, we have, for example, CH3, okay? We have C, then we have CH3, double bond, C, we have CH3, we have CH2, CH3. In the presence of ozone and then carbon tetrachloride. We are going to get the product which is going to be CH3, C, CH3, O, we have C, and then we have CH2, C, CH2, CH3. Okay? Okay? That is our ozonide. Ozonide. Remember, when you look at this one here, there is no hydrogen, Okay? So you get that one as our ozonide. Then, on hydrolysis of this one, CH3, C, CH3, O, C, CH2, CH3, O. Now we are adding water. You can say in the presence of water, zinc, and then ethanoic acid, CH3, COOH. The product you are going to get, who can suggest for us the product? Who can suggest for us the product you get here? We are going to have what? We are going to have, you look for this one here. No, sir. It's going to break like this. This one gives us what? CO. So we are going to have CH3, C, double bond, or CH3, plus there was a CH3 here. There's a CH3. There's a CH3 here. There's a CH3 here. C, H2, CH3, then you have CH3. So this one is going to give us CH3, C, double bond, plus CH3, which is this one, C, or CH2, CH3. So you get this one plus that one. So in case there is no carbon here, we end up getting what? Ketones. We end up getting what? Ketones. But if there was hydrogen, for example, here, we got an aldehyde, and then this one gave us what? A ketone. So you can use these ones here as well. Establish the position of the double bond. Now we can write one equation. We can write one equation. In this case here, for example, Eg. If I don't want to write all this, then I can have, for example, CH3, CH, double bond, CH2. Then I will put the first what? Step. First condition is that you add ozone in the presence of carbon tetrachloride. Then second condition is that I add water in the presence of zinc, in the presence of ethanoic acid, and room. So we are now winding all these steps here in one step. Ozonolysis and then hydrolysis. That means that after ozonolysis, first condition you get ozonate, then you come this one here. Ethanoic acid, room what? Temperature. Then here you are going to get CH3, CHO plus HCHO. So all those steps there, which I have been discussing, adding ozone in the presence of carbon tetrachloride to get ozonate, and then ethanoic acid plus water in the presence of zinc, that's hydrolysis to give you the final product. They can be summarized in one step. But we are giving this one here because in the previous question, there was a question here, describe. They just don't complete. Describe how you can oxidation products of this one can be obtained. So if you are describing, then you have to explain, and it carried about 5 marks. Okay, it gave 5 marks. Then we can also have ethene. Suppose I have ethene, double bond, CH2, still undergoing the same one conditions. The first one is I add ozone in the presence of carbon tetrachloride. Then next, I add water in the presence of zinc, in the presence of ethanoic acid at room temperature. At room temperature. Then I end up with HCHO plus HCHO plus hydrogen peroxide. Plus hydrogen peroxide. This one here hydrogen peroxide is an oxidizing agent. It's going to oxidize methanol to methanoic acid, HCOOH. So we get all of these reactions, we are getting what? Hydrogen peroxide, which can oxidize what? The aldehyde or to a carboxylic acid. That's why I'm using ethanoic acid to stop the reaction.
Teacher,
Yes?
the first equation, as we don't have the hydrogen peroxide,
Where?
first example you have given.
This one.
After the first one, we don't have hydrogen peroxide. No, that one down on that.
This one.
Down.
It's supposed to be there. Plus hydrogen peroxide. All of them hydrogen peroxide. All of them hydrogen peroxide, but is one of the byproducts. Because you're adding what? Ozone plus what? There is ozone and then what? There is water. After hydrolysis, the water will give us what? Hydrogen peroxide. Supposing I have this one, who can give us a product now? CH3, C, CH3, double bond, C, CH3, CH3. They are saying that in the presence of one, ozone, carbon tetrachloride, and then two, in the presence of water, zinc, ethanoic acid, 20 degrees what? Centigrade or room temperature. We have summarized. We have summarized that. What will be the product there? You remember that with organic chemistry, I mean, you are interested in the major organic what? Product. So in this case, you are going to get what?
Teacher,
Who can give us?
teacher,
Yes?
the carbon after double bond.
Which one?
The carbon after double bond. The other one up. Is it CH3 or CH?
This one.
Yes,
This is C.
up there.
3.
Yes, there.
C3. So can you give us a product? Who can give us the major organic product? Remember, the double bonds make what? Place, no? When you break this one, there is no hydrogen here, there is no hydrogen here. So it will give us what? CO, CO, not so. C double bond, O. So it's going to give us what? Two molecules of what? CH3, CO, CH3. That is our major organic what? Product. That's why here we say NB. Apart from ethene, which gives HCHO and methanoic acid, hierarchies give only carbonyl compounds as the product. So we have exhausted what? Ozonolysis plus the possible products which can be obtained. We have oxidized plus the possible mechanism product can be obtained. So NB in the above reactions, any aldehyde formed could be oxidized to carboxylic acid by the hydrogen peroxide. Any carbonyl compound formed could be oxidized by the hydrogen peroxide. So, in order to prevent
Yeah.
the oxidation,
Yeah.
yes,
Your third
yes,
equation, like when you were writing the second equation, you
yes.
said each of the equations have to give hydrogen peroxide. The third
Yes.
equation doesn't have hydrogen peroxide.
I'm going to put the major organic product. Okay?
Thank you.
But we can as well put what? Hydrogen peroxide. So in order to prevent oxidation from taking place, we said we add what? We add from taking place
Nicotinic acid.
hydrolysis of the ozonide is carried out in the presence of zinc and ethanoic acid. ethanoic acid. So, identification of the alkene. Identification of structure of alkene. Supposing you have carried out osmosis of the alkene, and then maybe the product you are going to obtain. Are we through? Are we through?
Yes.
Okay. I was giving these ones here instead of writing all the others. But from the previous question, I say your friends couldn't what answer that question because what they were told to describe. Okay. Now, if you just use what to these ones here, complete the following. You are adding ozone, the presence of carbon tetrachloride, water, zinc, ethanoic acid. Complete this one. Then they say explain. That means that you have to explain why you are adding what a polarizing agent, why you're adding what, why you're raising the presence of zinc and then what ethanoic acid to get all your marks. So basically, if they just the question said complete the following. Then you can just give that one. If they explain, we should now change our discussion. That what we also know how to discuss what how these reactions take place. Hello. So, to identification of the structure of alkene, we can say formation of R, C, O, H, and R, C, double bond, O, R, right? As the carbonyl compounds implies that the structure of the alkene is, we rewrite this one here to give us what? R, C, double bond, H, plus, we have O, double bond, C, R, right? R, O, double bond, C, we have, and then we have R, which gives us plus O, we just have O, double bond, C, so you have that one there also. Where there is O, double bond O, you remove the oxygens, and then what? You prolong. You look for that structure, which is going to give us R, C double bond. There is now H there. C para prime para dash dash. So just look at where the oxygens are, and then what? You combine them to give you the structure of the original alkene. So question, for example, when you combine these ones here, you can look at a sample question. Question, using equations only, show how 2-bromo-butane can be converted to ethanol. With the idea of ozonolysis, we can come that one there. So approach. We can heat it with aqueous sodium hydroxide. We can heat it with aqueous sodium hydroxide in the presence of ethanol. So CH3, CH, 2-bromo-butane, CH2, CH3. Remember we looked at what? Synthesis of the alkenes. We say that hot sodium hydroxide in ethanol to produce the ethoxide ion. This is going to give us but2 in CH double bond CH CH3. Then after that one, what we have been looking at is we can now have what? CH3, CH double bond CH in the presence of ozone, carbon tetrachloride less than 20 degrees centigrade. You get the ozonide. CH3, C, H, O, CH, CH3, O, you get the ozonide. Then carry out the ozonolysis of the ozonide. Carry out the ozonolysis of that one. We are going to have CH3, CH, O, CH, CH3, O. We said you add water. In the presence of zinc, and then ethanoic acid. Then you are going to end up with 2 molecules of CH3 CHO, which is ethanol. That is ethanol. So we're left with two reactions. That is reaction 7.
Yeah.
We're left with the two reactions after reaction 7. That's reaction with oxygen, reaction with bromine, water. Then we shall look at what? Reaction with then we shall look at what? Polymerization. So we're left with mainly three reactions. There is reaction with oxygen. Maybe we shall look at reaction with bromine, water first.
Yeah.
So next we shall be looking at reaction of bromine.
It's a question.
Yes, ask.
After on that answer given us, after the first equation,
Yes.
after the first equation, can
This
we
one.
write like the
After the first one.
the arrow? Can we put water down?
This one here.
No, like we write
Putting the arrow
one
down.
equation. We put
The arrow going down.
the
What?
second equation.
This one.
Yes.
Yeah, you want it right, like from here. I go downwards.
No.
Hey.
No.
Yes.
You write like the last examples you're giving us. You write oxygen and stroke carbon tetrachloride up and down. You write water and zinc, stroke the
It's okay.
whatever.
It's okay.
It's okay.
It's okay.
Okay.
If you want, you can what? You can jump this one and then you go direct, not so. You can say this one, then you put the first case, not so. Ozone, carbon tetrachloride, not so. Then 2 zinc, sorry, 2 water, zinc, it's an what? Acid. It's okay. But I wanted us what? To practice what I have been what? Looking at. So reaction 7 will be we are going to have a break and then what? Another teacher will be coming in. So reaction 7 will be reaction of bromine water, or chlorine water with alkenes. So on Thursday we shall what? We should be able to complete alkenes. And then we shall move on to another functional group. They have told him that you are done alkynes also. You are completed alkynes. Yes, no? Excuse me?
Obstructing us.
You are completed alkynes. Are you completed alkynes?
Please. No, sorry, we can't simply.
You can't what? You had discussed alkynes with Mr. Chisul. That means that I moved to what? Halogen alkanes. Okay. Any questions?
Harriet,
Yes.
yes. Could you like help me after the lesson, like with the beginning notes?
I'll meet you guys anyone.
Are you done copying work from the board? Are you done copying the work?
No, not teacher.
Copy very fast. I'm closing this session.
Who have questions?
Teacher, wait.
Questions?
When I get teacher, wait.
Teacher to papier.
I'm closing.
To papier. Wait for us.
Get teachers.
I'm taking the screenshot. It's on your
Who has all
WhatsApp.
the work people?
We're using laptop. You can
You guys
screenshot.
the work landing. Nange. Sikwambi in
Answer again, stopping your session.
Linda ko wende chingo to papier.
I'm really slow. You have to be fast women.
Covered.